Hello. Gary Draftscience came up with a really good experiment that I can't find done anywhere else for some reason. It's a good experiment. I thought a few people would have done it since he put this request up, but a week later I've not seen anybody having responded to it, so here's my attempt anyway, for what it's worth. And I know Gary won't accept it because it comes from me, but anyway, it's here nevertheless.
This is, there's got to be somebody out there, who's got a work table.
Let me think. Who do I know who might have a table? Oh, that's a difficult one, isn't it? Table. Specialist equipment. Can I book a table, please? You don't have any tables. You're a restaurant and you don't have any tables. Do you know anywhere that sells tables? Have you? It's a big square thing, or can be round if you name Arthur. A table, just any old table. Look it up in a dictionary. We need it urgently. It's for a groundbreaking experiment that should change the world forever.
And a this and a that.
Hello, have you got a this and a that? Or you've got them both in stock? That's fantastic.
Some hardware and likes to work with their hands.
Hello, I'd like to book a juggler, please. Thank you very much. Oh, and has he got any hardware he can bring with him? No, it's not for a party. No, it's for a science experiment. Sorted.
And wants to do, these are really simple experiments.
So why can't you do it then, Gary? Why can't you do it then, Gary? If it is that simple, and it is that simple, really simple, it's like throwing a ball against the wall, simple. Why can't you do it?
Yeah, maybe I'll just draw them.
Yeah, that's good enough, isn't it? Just draw them.
Yeah, maybe I'll just draw them.
Don't need to do them.
Yeah, maybe I'll just draw them.
Just draw the experiments.
Just to solicit it, because I really don't want to do the experiment. There is, just really is kind of inconvenient.
I was laughing so hard I broke my glasses. It's inconvenient. I'm going to play the relevant part of Gary's video in full. It's only 3 minutes, uninterrupted, so that I'm not messing with his claim. So you can judge what he says without me sticking my opinion in, okay? And then I will do the experiment and explain why I disagree with it. And by the way, I don't always disagree with Gary, not entirely anyway. For the most part, yes, I disagree with him because he does talk a heck of a lot of utter nonsense. But every now and again he says something where I think, he's got a point there. And sometimes the results of my experiments aren't quite as clear as I wanted them to be. They do show him to be wrong, but where I was expecting to see the spring compress double the amount with the half mass, twice speed object hitting it, and I find out it only compresses it half as much again, that kind of surprises me because I expected to see it compressed double. And then some of the experiments do show it literally doubling, and so that puzzles me even more. It's more a question mark over the mathematics of the experiment that I don't really entirely follow as it applies to the different types of tests. Compressing springs, moving things involving friction, or generating electricity. I think you need a very mathematical, well-rounded physics brain to make sense of all the different results. If you've got a simple layman's brain like me or Gary, then you're going to look at these results and say, hold on a minute, these are only half right. And that's the position I've been in sometimes. It is complicated stuff to us people who aren't really mathematically inclined. You do need a mathematical brain to stay on top of things. I don't have a mathematical brain. Gary clearly doesn't either. But like I say, I don't always disagree with everything he says, especially about things like the set experiments. Look, I need to give some examples because I'm shooting my mouth off a little bit here, and I need to just show you something to back up what I'm talking about. People frequently say only wave theory supports diffraction, and I can show particles in the macroscopic world, so to speak, displaying diffraction. Let me just give a quick example that's nothing to do with this video really, but I've opened my mouth, so I better back it up with something. So for instance, yesterday Gary got a message that he read out, someone criticising him for having a particle theory as opposed to the wave theory of light. And as usual, most people say, oh, there's no way that particle theory can explain diffraction. But as I've said before, even I can show a particle in the macroscopic world diffracting. Most people are in agreement that light has a particle aspect and that light has a magnetic aspect. Therefore, why can't we model a photon as a magnetic particle? Because if we did, and I can demonstrate that's actually happening in the real world, in the macroscopic world, a magnetic particle would diffract. It doesn't have to be a wave. It would give the appearance of a wave while actually being a particle in the macroscopic world again. In the real world, where we can actually physically use our goggles and say, look, I can see this diffracting. It's a magnet and it's diffracting. Let me show you what I mean. Anyway, this is going a bit wide of the subject of this video, but just for something a bit different, just for a minute. This is called the LENZ'S law breaking effect. When the magnet passes between the copper pieces, it induces current in them, and that current always opposes the motion. So if the magnet wants to roll away, it tries to pull them back. If it wants to roll towards them, it pushes them away. That mimics the same effect as passing through a slit. People sometimes ask on physics forums, what is the physical cause of diffraction of light going through a slit or whatever? And the explanation is always analogous. They start talking about soldiers marching arm in arm and walking through, on one side of them walking through soft ground while the others remain on hard ground and stuff like that. The same explanation for refraction. But if you apply LENZ'S law to any of these problems, LENZ'S law 100% perfectly explains refraction and diffraction. Well, it doesn't like going down the middle, does it? Even though that looks like the most obvious path. Yeah, methinks I may have moved this one too far back. Give it a few more goes. Oh, perhaps I was wrong. That was quite a sudden deviation. If it's this hard to predict which way a simple magnetic ball will go, how hard would it be to guess which way a photon would pass through a slit? Would it swing this way? Would it swing that way? Assuming there is a connection. And I like to think that there is, because there seem to be so many commonalities. Again, that was another freak, very wide swing. Matching that one. I think I'll stop there. Just to make it as clear as possible, I'll draw in heavier pen. So you can't really argue that diffraction and other phenomena that depend on diffraction, such as single slit interference, you can't claim that those are specifically fundamentally a wave phenomena and can't possibly be a particle phenomena when I'm showing you nature. I've not made that happen. Nature made that happen. And if we're expecting Gary to accept when nature shows us other things, like the kinetic energy formula playing out in real life, we also have to be willing to accept seeing nature showing us that particles, at least in the macroscopic world, can do the very same things that are supposedly only possible with waves. It appears not. And here is some evidence that if light really was a magnetic particle, how it would explain total internal reflection, how light and microwaves, etc. propagate through waveguides. Especially interesting when they propagate through twisted waveguides, effectively the equivalent of the so-called triple polarizer paradox, which is just a crude form of that. I've got a little video about that separate. Maybe I should slot that in here. Why not? It's only a minute. This is a little radio transmitter. That's the antenna. It's transmitting in that polarization. The receiving antenna has to be the same polarization. Now we can transmit that signal down this tube that way, but we can't transmit it that way. This is like a polarizing filter. It will let it pass that way, block it that way. This is called a waveguide. If we put two waveguides end to end, the signal gets through. But if I twist one of them so that they're different polarizations, no signal can get through. One's blocking that and the other's blocking that. So no signal gets through. But we're all supposed to be amazed that when we put a third one in the middle at an angle that light can get through again. But it's not amazing because that's just a twisted waveguide. It's the same as this in very crude form. You can guess how that works. It goes in one orientation, comes out the other. It's coaxed into changing direction, just like a link road between a road going that way and a road going that way. A link road at 45 degrees coaxes your car into changing direction from that way to that way. But it couldn't do it suddenly. They have to be coaxed around gently. So triple polarizer paradox is nothing more than a twisted waveguide in very simplistic form. Nothing gets through like that, and nothing gets through like that. But halfway between the two, it does. I'm using this to illustrate the triple polarizer paradox. It's not a paradox at all. You are just introducing a very crude turn in the middle, a very crude twisted waveguide. The polarization was meant to go that way, but it's receiving that polarization. But when we put the equivalent of the triple polarizer paradox device in the middle, it corrects the polarization. Same as if I put this at a 45-degree angle between the two. Nothing gets through like that, and nothing gets through like that. But halfway between the two, it does. So that was just a cruder version of that. If you had several of these waveguides gradually turning 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until you turn the 90 degrees, you would get almost the same effect as that. Triple polarizer paradox is nothing more than a twisted waveguide in very simplistic form. Oh, we can demonstrate total internal reflection the same, zigzagging through a slit. Photons probably zigzag through because they have no choice, because effectively they're invoking LENZ'S law in a fashion. That's what's happening here. It's all caused by LENZ'S law. The ball's being pushed and pulled left and right. It's zigzagging through. It's zigzagging between the aluminium foil rolls because of the current it's inducing in the aluminium foil rolls. And for those of you who don't know, this is actually how a waveguide works. The photons are effectively reflected back and forth. They zigzag through a waveguide, which is what governs the dimensions of a waveguide. I'm not entirely sure how this might play out in a dielectric, but we certainly do have dielectric waveguides.
You have two really simple experiments. But I mean, you have two really simple experiments. I mean, just take any kind of spring loading device. I mean, you're just saying you're going to take a spring and compress it a certain amount. I mean, all you really want to do is put any kind of object on it. So even if you shot them off the edge of a table, in this direction, and you're just going to take a 2 mass and a 1 mass and do the experiment with those two different objects. Place one in and see how far it goes, put two in, see how far it goes, and the idea will be is they will fall at the same rate in the gravity, so that saves us some trouble. And the idea would be is that the light one will fall twice as far, it'll go twice as far away as the heavy one, and proving that the momentum is conserved, that this one will leave with twice the velocity, which means, that I can compress springs with heavy objects and shoot springs with light objects, and I can double my energy. So there is free energy. So it will prove free energy. Okay, so let's just understand that this experiment decides the question once and for all. It basically says if it doesn't land here and instead lands here, okay, that'll tell us that, oh, okay, well, it can't land here. It has to land in the same place, actually, to conserve the energy. This one, the lighter one, has to land in the same place as the heavy one, which it's not going to do. Well, let's just think energy-wise. Yeah, no, well, here's where they're saying it would land. 1.4. So instead of 2x, it'll only go 1.4x. All right. And, I say that logically you can understand this can't be the truth. This bullshit can't possibly be the truth. But whatever. That's a simple experiment. You just film that and just, there. There's different ways to do it. You can roll things, but I mean, rolling always involves turning something, spinning it, and then the rotational energy becomes part of it consumes some of the momentum. So you don't want to really force things to roll or do different things because that'll distort the results. It probably wouldn't be enough to throw it that far off, though. I mean, air resistance, different things are going to get in the way, but there are tiny differences in the effect.
Hello, please forgive me if this presentation is a bit mixed up. I can't get everything. I can't think straight because I'm suffering with, the COVID crap. So my brain's all fuzzy and I'm struggling to edit all these bits of information together. So forgive me if there's any repetition in here and if I'm not showing you the information in the most logical order. It's all here, but you might have to sort of hunt around a bit. I think I put the experiment at the end. And it's not that long. It's only half an hour, I think. Anyway, my apologies. I'll try and do better next time. I've not put any music on. I've not put any pop stars on, giving Gary the wanker sign. So he's got nothing to moan about. I've even been quite kind to him in some respects. Hello. This video is about a simple but good experiment proposed by Draftscience to debunk the theory of kinetic energy. The only snag is it debunks all his claims that he's been making for over a year.
This one will leave with twice the velocity.
No, it won't.
Which means I can double my energy.
No, you can't, because it doesn't go twice the speed in the first place.
So there is free energy.
No, there isn't.
So it will prove free energy.
No, it will not.
This experiment decides the question once and for all.
And yet you're not willing to do it. Isn't that remarkable? Isn't that telling?
Because I really don't want to do the experiment.
And that's the truth.
Because I really don't want to do the experiment. It just really is kind of inconvenient.
Because it's going to prove you wrong, and you know it.
It just really is kind of inconvenient.
Oh, what a surprise.
If it doesn't land here and instead lands here,
that will be perfectly normal, taking into account air resistance.
That'll tell us that
Gary's wrong and has been wrong for over a year. As far as he's concerned, this will prove once and for all that the theory of kinetic energy is rubbish. I maintain the opposite point of view because I've done the experiment. Gary refuses to do the experiment even though it's his idea. He says it's inconvenient. Well, it's inconvenient to me. I've currently got coronavirus, tested positive today. I'm feeling a lot better than I did yesterday and the last few days while I was doing the experiment. But I've made the effort even so, because even though it's inconvenient to me to video it numerous ways, knowing that Gary will pick on the slightest thing, even though I make no claims to be a scientist, I'm a layman just like him. The difference is I listen to what the scientists and I test claims that people put to me. Anyway, so here's the experiment. It's a very simple experiment. Basically, Gary suggests, why don't we, it is a good experiment actually, he simply suggests, why don't we simply use any, and he does say any, spring-loaded device. So why not an M10 Bic pen? Because you can buy those all over the world, so anyone can recreate this exact same experiment and check my results. He says, why not just get any spring-loaded device and use it to project, to fire any, and again he says any object, so I've chosen British coins, and see whether the one mass really does go twice the speed of the two mass object. That's his claim. He claims that a one mass object will go twice as far, twice as fast as a two mass object, and he says we can use any spring-loaded device to fire off any object, even off a tabletop, and measure the distance, and that will be a good measure of whether his theory is correct or kinetic energy theory is correct. If the ratios are 2 to 1, then kinetic energy theory suggests that the one mass object relative to the two mass object will go 1.414 times faster, pushed by the same spring force or whatever. He disagrees with that. He says it will go twice as fast, twice as far. Anyway, here's the experiment. Enjoy. Tell you what, I'll put the actual experiment at the end so you can just jump to that if you want to. But here I'm going to show you the results in like a compressed format, so it'll only take about 3 minutes to talk about it and illustrate one of the main objections that Gary is going to pull out. I'll deal with that as well. Best to get these things out of the way early.
Okay, Gary's proposed weight drop experiment. I'm going to drop 3.2 gram coins, UK 5p pieces, which are these. I'm going to drop those from a height of 92 centimetres. There's your proof. I'm going to measure in either inches, I've written there to make it convenient for you to read off because it's going backwards really, or centimetres, decimetres for an easy read off scale there. Let's see how far these fall off in accordance with Gary's predictions. So what we can see that 10 of these weighs 33 grams.
And 1, 2, 3, 4, 5, 6, 7, 8, 9.
10 of them weighs 66 grams, exactly double. Okay, so 66 grams, 33 grams. 3.3, 6.6. So I've noted it there. 3.3 grams and 6.6 grams as the doubled up ones, as you can see. Now I'm going to push them off the edge using these standard Bic M10 retractable pens, because you can buy those anywhere in the world, so anyone can repeat this experiment. To push them all off the same every time, okay. I'm going to use silver foil as a way of marking where they land. So, blue ones, so as we first go, I'll release. You can see very clearly where it landed, can't you? That worked out quite well. So it's on the 5 mark, isn't it really? So I'll put a dot there, okay. Set the next one up. Off we go again. Ooh, how did that do? Exactly the same place, isn't it? Look.
You get the idea. I do that 10 or 20 times, then do the same with the red ones 10 or 20 times. Mark off either the averages or mark off the fastest ones.
Third go. Oh, just a little bit short of the other one, can you see? So it's the red ones, isn't it? The one mass. Crikey, where did that go? There, it's hit edge on there, hasn't it? A little bit short of what science predicts, and a lot short of what Gary predicts. Next one. So let's look at the table this time. This is a record of the 92 centimetre drop. You can see that the two mass object went 19 inches. The one mass object went 24 inches. That's 1.26 times that. And science predicted 26.9 inches, 1.4 times that. And Gary is all the way over here. He predicted it would go 38 inches, double that. Actual, science, Gary's. Whose looks most right to you? This is what happened when I dropped from 61 centimetres. 61 centimetres. 61 centimetres. The two mass object went at 14.65 inches. The one mass object, the single coin, landed at 19 inches. Science predicted it should have landed at 20.7 inches. In other words, 1.414 times 14. And Gary predicted it would go, what's 14.65 doubled? Oh yeah, 29.3. Yeah, Gary predicted 29.3 inches, double that. Okay, let's see if I can repeat that experiment from 61 centimetres. Okay, so the two mass object first of all looks to be going a bit further than it did last time for some reason. Further still. Same there again. From 61 centimetres this. Can't see that. We're looking for the furthest it ever goes. Because there may be flukes where it doesn't go as far, But you're not going to get flukes where it goes further, are you? There again. Right there. The one mass object now. Can't quite see where that went. Oh yeah, there's a round mark there, isn't there? High speed camera would be handy. Can't see where that went really. Can't see where that went either. Oh, that's it there, isn't it, of course there. How could I not see that? Pretty much again, I guess. Okay, so the best results in each case were 14.7 for the 2 mass, and I'm using this board as a square. 18.8. Do the calculations. And that's a summary of the result. It was a bit better last time, but we've concluded this time it's 1.28. So 2 mass went 14.7, 1 mass went 18.8 actual. Science predicted 20.8, Gary predicted 29.4, so at least science is in the ballpark, and quite obviously it's air resistance causing this difference. The result was a bit better last time when I did this, came out at 1.3 instead of 1.28, and then the next one came out at 1.36 when I did it from a much lower height, 32 centimeters. For the record, this is what happened when I did it with the drop 32 centimeters. 32 centimeters. The 2 mass object, 6.6 grams, went to exactly 10 inches, and the 1 mass object actually landed at 13.65 inches, and that was just short of what science predicted. Science predicted it would land at 14.14 inches, if I could measure that accurately, and Gary predicted it would measure all the way over here at twice the distance, 20 inches, double that of the 2 mass object. So Gary's prediction was way off.
Returning to the 92 centimeter drop one, just for a moment.
Now Gary's common excuse, Gary likes to blame the spring that you use to propel the object, saying that it's not strong enough. He likes to tell us all that it's not strong enough to respond quickly enough to send anything at that speed, that far. So let's test that out at 92 centimeters, then test it out again at 61 centimeters height, and test it out again at 32 centimeters height. And every time you'll see that the spring is quite capable of projecting objects much further than Gary claims is the limit. It's a desperate excuse on Gary's part, I'm afraid. I don't really want to hammer it home to him, but I just want him to accept the reality, the honest truth, that this is what's happening. He's fighting Mother Nature, so to speak. He's not fighting me or anyone else, he's fighting reality. Sorry, that's the way it is. Anyway, it's very difficult to film this, so I've put the camera dead high up and it's a bit dodgy. I'm hoping so you can see that I'm launching it from the same place and it's travelling more than this 1 metre over a yard past Gary's projection, which is here, and well past the science prediction. So the 1 mass object is not limited by the spring stiffness, as Gary claims. Very well. Where the fucking hell did that go? Well, I'm afraid that went off the table. It went too far. I'm going to change the angle a bit. There's a catchment area here. I'm hoping to catch the object in. These are not pointing the right way at all. Try that. I don't know the best way to do it, really. Right. Well, did you see that? That hit the backboard and bounced there. I'll do it again. Again, you can hear it hit the backboard and bounce all the way back there. So they're all going as far as this channel will let them.
Stupid objections are his only defence. He's not arguing with me, he's arguing with nature. He's not facing reality. That's not my problem, it's his.
Because I really don't want to do the experiment.
And that's the truth.
Because I really don't want to do the experiment. It just really is kind of inconvenient.
Because it's going to prove you wrong, and you know it.
It just really is kind of inconvenient.
Oh, what a surprise. It's inconvenient for Gary to do an experiment that he says is the simplest experiment in the world.
Really simple experiment.
The most important experiment in the world.
So it will prove free energy. That
will settle this once and for all.
This experiment decides the question once and for all.
And it's inconvenient.
Just really is kind of inconvenient.
How convenient that it's inconvenient for you.
Because I really don't want to do the experiment. Really simple experiment. I mean, just take any kind of spring-loading device.
Remember that, folks.
Any kind of spring-loading device.
Remember that when he makes his excuses in a minute.
All you really want to do is put any kind of object on it.
And remember that too when he makes his excuses.
So even if you shot him off the edge of a table.
And remember that too, he's not particularly fussy what the objects are pushed off. So let's summarise. He's not particularly fussy what surface these things are pushed off. He's not particularly fussy what pushes them off. He's not particularly fussy what's being pushed off. All he cares about is that something is being pushed off by a spring off a surface and that we're measuring the distance it travels. Because whether they're one mass or two mass, they will fall at the same rate. Therefore, you can read off the distance they travel before they hit the surface, and that gives you a direct indication of the velocity that they were travelling. And he predicts that the half-mass object will travel twice as far as the one-mass object. And he's wrong. It doesn't happen that way. But he's going to be in denial because this is his religion. It really is a religion. He accuses us of having a religion by believing what we see with our eyes and what we test. He won't test this, even though it's his idea and it's a good idea. He won't test it because it's inconvenient. Well, it's inconvenient because it's going to prove him wrong. I plead with Gary to somehow get past this. Do the test. Stop saying it's inconvenient. Make the effort. He himself says it's such a simple experiment. What possible reason could he have for not doing it other than the fact that if he does it, then he can't point the finger at anyone else? That's the real reason he won't do it, because if I do it, he can point the finger at me and say, oh, you didn't weigh the coins right. Oh, you shouldn't have used coins. You shouldn't have used a retractable pen to find the objects. Oh, you shouldn't have done it from that height. Oh, you shouldn't have done it. You should have done it in a vacuum chamber. God knows what excuses he's going to come up with. But sure as eggs are eggs, he's going to come up with an excuse because he has to. His mental state of mind depends on him having an excuse that he can sell to all the numbskulls who believe every word he says. And the biggest numbskull of all is himself. He's got to kid himself that he's right. So here I am, tested positive with COVID, not been well all week. I'm on the mend really a bit now. And I'm doing an experiment that he refuses to do because it's inconvenient. It's inconvenient. I don't want to have to do the experiment, he says. It's inconvenient. That's pathetic. Absolutely pathetic for the man who claims to have more integrity than anyone else on the planet. Laughable. Laughable. He will only be fussy when he's proved wrong.
And you're just going to take...
Did you notice what he said? He said, you're going to take a two-mass object or whatever. You, not him. We, they, you.
And you're just going to take...
He has no intentions of ever doing these experiments. You could put him in $1 million laboratory, and he wouldn't do the experiment. Because he knows he would be wrong. Why would he do an experiment that's going to show him to be wrong? Even he's not that dim.
And you're just going to take a 2-mass and a 1-mass.
And remember, right up until the point of him being proven wrong, he says these can be any objects.
Put any kind of object on it. Place one in and see how far it goes.
Like this.
You can see very clearly where it landed, can't you? That worked out quite well. So it's on the 5 mark, isn't it, really? So I'll put a dot there, okay? Set the next one up. Off we go again. Ooh, how did that do? Exactly the same place, isn't it? Look. Third go. Ooh, just a little bit short of the other one, can you see?
Somehow this won't be good enough for Gary. We all know how fussy he suddenly becomes when he's proven wrong. Not so fussy before though, is he? He never is.
Put 2 in, see how far it goes.
You can see very clearly where it landed, can't you? Last one of the blues, that's 10 blues, isn't it? 10 of the 2 mass ones. There we go. Same again. Swept an arc through all those points. I've drawn a line through the tape measures so that we can then calculate what Gary's prediction is and what science's prediction is. So it goes exactly through 19 inches.
They will fall at the same rate.
Absolutely true. Unusually for Gary.
And the idea would be is that the light one will fall twice as far.
So if Gary's right, then we should be looking for 38 inches, like this.
So I've now drawn arcs through all of those points. Use the square to mark the average 24 inches. And
Oh dear, that wasn't supposed to happen, was it? Oops, here we go again. This is where Gary and reality go separate ways.
Go twice as far away.
If you could make that happen, you would be one of the world's greatest magicians. So try it. I don't think you are a great magician, so you can't make it happen.
As the heavy one.
Everybody but Gary knows it will follow the kinetic energy formula. It will go the square root of 2. It will go the square root of 2 times the distance. If the ratios were 3 to 1, it would go the square root of 3 times the distance. If the ratios were 4 to 1, it would go the square root of 4 times the distance. You moron.
This one will leave with twice the velocity.
No, it won't.
Which means that I can compress springs with heavy objects and shoot springs with light objects, and I can double my energy.
No, you can't, because it doesn't go twice the speed in the first place. You moron.
So there is free energy.
No, there isn't. You moron.
So it will prove free energy.
No, it will not.
This experiment decides the question once and for all. This experiment decides the question once and for all.
And yet you're not willing to do it. Isn't that remarkable? Isn't that telling?
If it doesn't land here and instead lands here,
that will be perfectly normal, taking into account air resistance.
That'll tell us that
Gary's wrong and has been wrong for over a year.
Oh, okay. Well, it can't land here. It has to land in the same place.
Gary, I really do urge you to just take a little bit of time out. I won't make a fuss about it. Take some time out and think about this. And I, for one, won't make a fuss if you just say, okay, fucked up. Because that's the honest truth. I understand how you come to these wrong conclusions up to a point. But the only reason you've not managed to correct yourself so far is because you've been too proud to accept that you've made a mistake. And that even an idiot like me can correct you.
The lighter one has to land in the same place as the heavy one, which it's not going to do. Well, here's where they're saying it would land, 1.4.
Well, yes, it really is a simple experiment, and yes, it will go 1.4 times the distance, accounting for air resistance. Why is that something to mock? Why are you trying to mock nature, reality?
So instead of 2x, it'll only go 1.4x.
Correct. Test it. Do it. It is a simple experiment, as you rightly said at the start. Your only flaw is your utter refusal to do the experiments that you propose. And you've been taking this hypocritical position for over a year now. And you don't like it when someone calls you out on it. You, supposedly the man with the most integrity of all the people in the world. How you've come to that conclusion, I will never know.
Logically, you can understand this can't be the truth.
You might as well say an apple falling on your head cannot be the truth. You're an idiot.
This bullshit.
If you think that nature is bullshit, then it's you who's running a religion. And as religions go, yours has to be among the very worst.
It can't possibly be the truth.
Ask yourself, Gary, how unscientific it would be for anyone to presume the outcome of an experiment before they've done it. You are forcing yourself into some kind of confirmation bias situation. But I have no idea how you can possibly resolve something that Mother Nature shows you very clearly. Mother Nature is trying to tell you something, and you are not listening to Mother Nature. You're listening to your inner voice. Don't listen to me, don't listen to your inner voice, listen to Mother Nature. Do the experiment as honestly as you can. I have no idea how you could possibly cheat this experiment. I don't know how I could cheat this experiment, other than blatantly lying about the weights of the objects, the masses of the objects. But they would have to be so different to what they should be, it would be obvious that you were cheating. Plus the fact that the experiment is so easily repeatable, anyone can do it. Anyone but you, apparently. So anyone could prove whether I'm right or wrong. Anyone can verify these results that I'm showing you. Even you. Even you. Even you. But you just won't do it because that means that you are going to have to face reality from then on. And I can understand why that must be difficult. I promise not to take the piss if you just accept the reality. Because I do have some sympathy for you. I'm not entirely against you. You think I am. I'm only against you when you're wrong. Look, let me give you an example of where I think you're right. Hang on, I've got a book here somewhere. This book I bought the other day. Microwave Optics, different topic. Published by Philip Harris. There's a page or two in this that's completely wrong. And I've got two other editions of this. I think this is 1979. And I've also got the 1960s version and the 1980s version, where they completely get it wrong about single slit interference. Even you know that it is wrong. Everybody should know that it's wrong what they're saying here. And I want to show you about that because
That's a simple experiment. You just film that.
Look, you don't even need to film it, Gary. You can either mark the objects with coloured paint so you can see where they land, or you can make it so they land on something where they leave a mark. Tin foil, kitchen foil. You don't need to record it. You don't need a high-speed camera. It would be interesting, yes, but you don't need it. You can accurately measure how far they go with silver foil.
There. There's different ways to do it. You can roll things.
What are you on about? We can roll things as they fall through the air. Why would we want to do that? There's no need. I'm just projecting flat coins, and they stay flat. You can tell they stay flat because they leave a different mark depending on which way they land. And you can see that they haven't tumbled particularly. They've stayed flat. And they've landed the same way up as they were shoved off the shelf by the pen spring.
But I mean, rolling always involves turning something.
You don't say. Rolling something always involves turning something. You're a font of knowledge, you are, Gary.
Spinning it, and the rotational energy becomes part of the... It consumes some of the momentum.
This is all irrelevant, Gary, because we're not rolling things. We're firing things through the air. I think you're just adding extra information, unnecessary information, to try and sound clever.
So you don't want to really force things to roll.
You already know that rolling things is irrelevant to this experiment.
That'll distort the results. Probably wouldn't be enough to throw it that far off, though. I mean, air resistance, different things are going to get in the way, but there are tiny differences in the effect.
I'm going to force you to remember that you said that.
Okay, Gary's proposed weight drop experiment. I'm going to drop 3.2 gram coins, UK 5p pieces, which are these. I'm going to drop those from a height of 92 centimetres. There's your proof. I'm going to measure in either inches, I've written there to make it convenient for you to read off because it's going backwards really, or centimetres, decimetres for an easy read off scale there. Let's see how far these fall off in accordance with Gary's predictions. So what I'm going to do is I'm going to first of all use single 5p coins for the one mass object, or half mass you might call it. Then I'm going to double them up like this, two strapped together. But because the tape is going to add a bit of weight, and because two strapped together is a slightly different dimension, so it'll have slightly different aerodynamic characteristics, I'm going to make these the same shape by adding some tape to them all. See, I make them about the same thickness by sticking some double-sided tape on, and colour them red or blue. Red being the half mass object, same as I've always done. So we now have 10 of these coins made double thickness, half mass but double thickness. Got to cut them up. There's 9 there, and that makes 10. Okay, so we can see that 10 of these weighs 33 grams, and 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 of them weighs 66 grams, exactly double. Okay, so 66 grams, 33 grams. 3.3, 6.6. So I've noted it there. 3.3 grams and 6.6 grams with tape and shape compensation added to the single coins. In other words, I've added thickness to them, just so that they're the same thickness as the doubled up ones, as you can see. Now I'm going to push them off the edge using these standard Bic M10 retractable pens, because you can buy those anywhere in the world, so anyone can repeat this experiment. To push them all off the same every time, okay. I'm going to use silver foil as a way of marking where they land. So, blue ones, so it's my first go, I'll release. You can see very clearly where it landed, can't you? That worked out quite well. So it's on the 5 mark, isn't it really? So I'll put a dot there, okay? Set the next one up. Off we go again. Ooh, how did that go? Exactly the same place, isn't it? Look. Third go. Ooh, just a little bit short of the other one, can you see? Hey, this is not bad, is it? I went there, didn't it? I'm not sure about that one. Same place again. That's the one there, yeah. So you can see the circle there. Because they're all in the same place, it's difficult to spot. But anyway, at least we're getting a consistent result. I can't see where that went. Oh, is that it there? So this time I'm going to focus on the table so we can see where it lands. Okay, 3, 2, 1. Whee! Where'd that go? Last one of the blues. That's 10 blues, isn't it? 10 of the 2 mass ones. There we go. Same again. Okay. Well, they're all just shy of 5 decimeters, aren't they? 500 millimeters, half a meter. So by right, if Gary's right, the red ones, half the mass now, should go right to the end almost. Just short of the 1 meter mark, 9.5 decimeters, 950 millimeters, 95 centimeters. There's too many ways of saying it. So if Gary's right, it should be over there. If the square root of 2 is correct, then it should be about there. 6.5, I would say. So I've now swept an arc through all those points to see where the concentration lies there. Put a set square there, so I've drawn a line through the tape measures so that we can then calculate what Gary's prediction is and what science's prediction is. So it goes exactly through 19 inches, so that's 38 inches, which is just off my scale, so I'll have to add a couple of inches on. So there, I've added a couple of inches on. That's where Gary predicts the half mass object, the single coin, will go. 3.3 grams.
Oops, I was a quarter of an inch off there, wasn't it? Doesn't make any difference though, because the half mass never actually gets anywhere near Gary's prediction.
Okay, so I've marked all the predictions now for the various masses. So this is the one we've just done, the 2 mass, 6.6 grams. Then this is what science predicts half that will go to. Gary says no. Gary's prediction is it'll go twice the distance, 38 inches. Now that's where science predicts that a quarter mass will go, because that's the square root of 4 times 19. Square root of 4 is obviously 2 times 19, 38 inches. Just to do an odd one, let's do a third of that mass instead of a quarter or a half. Do a third, so that's 0.66 mass. Science predicts the square root of 3 times 19. Square root of 3 is 1.73, so 1.73 times 19 is 32.9 inches.
With thanks to John Walker and Piro and 1 or 2 others, I dare say, who a few months ago were trying to get the point across to Gary that there's no such thing as this 1.414 thing. It's the square root of whatever ratio you were talking about. Where there's a 2-to-1 ratio, it's the square root of 2, which just happens to be 1.414. But where the ratio is 4-to-1, then it's the square root of 4. Where it's 3-to-1, it's the square root of 3. And if it was 3 and a bit, it would be square root of 3 and a bit. Or so was my understanding anyway. So Gary, there's no 1.414 thing. It just happens to be the square root of 2. And John Walker kept saying, stop using 2-to-1 ratio items. Do something else. Do 2.1 ratio or whatever. Anything other than 2-to-1. Because 2-to-1 will always give you this 1.414 thing. Because 1.414 is the square root of 2. Of course, they don't give you a specific lesson in the square root of 2, Gary. Gary kept saying that he had doubts that anyone took lessons in 1.414. Of course they didn't. We didn't have lessons in the number 9 when we were kids. And yet the number 9 does exist.
So it's the red ones, isn't it? The one mass. Crikey, where did that go? There, it's hit edge on there, hasn't it? A little bit short of what science predicts, and a lot short of what Gary predicts. Next one. So let's look at the table this time. So we had one there and one there. So perhaps that was a bounce. Perhaps that was a bounce. Ignore that then. Scrub that one out. I've drawn a pair of tits, haven't I? Didn't mean to do that. You see, I'm looking through the camera when I should be looking at the actual table, then I'll get a better idea. But it all happens so fast, and when you're dog tired, here we go. That's a lovely clear one. This is less than science predicts, in fact. It's certainly less than Gary predicts.
I later discovered that I'd made the drop height a bit too big, and that when I tried doing a couple of experiments where I dropped the height and then dropped it some more, and I discovered that the results get closer and closer to the predicted scientific results, closer and closer to the square root of 2 or the square root of 3, the square root of 4, etc. So in this example, I think I'd only achieved something like, was it 1.2 something? Sorry, it should have been 1.414 in a perfect world with no air resistance, etc. Unfortunately, I've mislaid my vacuum chamber. Joke. You never know what Gary's going to believe, do you? You believe I make my own cathode ray tubes. That was a joke. Anyway, so I'd made the drop height too big. I reduced the drop height by a third. When I reduced the height to about 61 centimeters, the results went from being 1.26 times. The results came through at 1.3 times instead. So then I reduced the height a bit more to, yeah, I just checked. So then I reduced the height to 32 centimeters, just over a foot, about 13 inches. And the results came through then at 1.36 times instead of 1.414. So you can see that when you don't make the drop height too excessive, the results get closer and closer to the scientific prediction. Now, if we could eliminate air resistance, I'm sure we would achieve that 1.414 quite easily. But we're never going to achieve 2 times, which is Gary's prediction. Anyway, so there you go. If you don't make the drop height too great, then you quite easily verify the scientific predictions. Sorry for my appearance, by the way, but I think I might have a mild version of COVID because some friends have got it and they've asked me to do the lateral flow test again. But this time I do feel a bit I couldn't do the test because it messes up the test anyway, so I'm just having to guess at the moment that I've probably got it. The mild Omicron version, I imagine. Anyway, I don't feel very well at the moment, so that'll be why yesterday I was dog tired while I was doing this experiment. You know when you just don't feel up to doing anything? But I wanted to get it done because I thought Gary's idea was a good idea. I think he's copying off Bruce Yeeney's test that he's done with school children or someone like that. There are some fantastic YouTubers out there doing science, for school kids, and we can learn a lot from them, simplifying experiments. And all he's doing is a similar thing to what Gary described.
Here we go again. You can see that mark lovely and clear. Same again, I can see that nice and clear. There. Next one. Okay, so they're all in the same ballpark, aren't they? So I've now drawn arcs through all of those points. And now I've used the square to mark the average of those 24 inches instead of science predicted 26.8. So I've documented it was shy of what it should have been. It should have gone from there to there, but instead it's gone from there to there. Gary predicted it would go from there to there, so Gary's way off. Right, I found some old half-new pennies, as they were called, in the 1970s and 80s, a defunct British coin. Those weigh 1.8 grams each, so I'm going to have to wrap some tape around them to try and make them into 0.6. That one there, 0.66. There you go, right, I've separated them now, I've trimmed them, I've added a little bit of plastic to each to make sure that they're all exactly 1/3. Science predicts that they should land here. Let's not build the hopes up, so here we go. Oh. Wasn't bad actually, it was there. Better than expected. I'm marking in green here, okay. Well, I would if the pen worked. It also proved to Gary that he's going to argue, we know how his brain works, he's going to argue that this spring isn't capable of accelerating anything any further than that. But we've proved it by the fact that it's accelerated this further already. So we can't claim that the spring isn't stiffing off that garbage. Here we go again. Mark. I'm going to have to be quick because battery's dying. Yeah. Where did that go? That was there. Next one. That was there. There. 3 more to go. Penultimate one. 1 minute to go on the camera. Last one. Okay. Remark them to make it easier to understand what's going on. Okay. Now that third mass should have been there by science rules. Air resistance must be causing a problem, mustn't it? It's got to be air resistant, hasn't it? And I've run out of camera time to do the quarter mass one.
I might have caused some confusion by saying a quarter mass, then showing a notice saying 0.5 mass. Well, 0.5 mass is a quarter of the blue mass. The blue one was 2 coins strapped together, 2 mass. So a quarter of that would be half a coin, 0.5 mass, a quarter. So then you have to use the square root of 4, which is 2. 2 2s are 4. Yeah, so if you wanted to achieve the twice distance, the twice velocity that Gary says we should get, you have to use a quarter of the mass, not half the mass. And that, to the best of my knowledge, which isn't much, is the kinetic energy formula.
I think we can safely guess it would have ended up about here, short of what it should have been, because there's a trend, isn't there? They're all a bit short of what they should have been. And I've run out of camera time again, folks. You didn't get much chance to see my pretty face, did you? Lucky you. Didn't even get a chance to show you the air track working. We've got the light out there. Oh well.